Okay, this is Mr. Anderson for Kellogg Community College. We're going to be doing some problems out of 7.4, and I want to deal with some of the patterns, the difference of square patterns, and some of the other trickier factoring that we've seen before. Now, we're going to deal with problems numbers 15 and number 60. Now, in the difference of squares, this is problem number 14. In the difference of squares, we're going to take a look at 49y to the fourth minus 16. Now, the first thing is that in a difference of squares pattern, we got to make sure that the numbers are perfect squares. Is 49 square rootable? Yes, it's 7. And is 16 square rootable? Yes, it's 4. Is it a difference? Is there a minus sign? Yes. So far we have a difference of squares as long as the power is an even. And y to the fourth is an even power, so therefore everything checks out. So here is our pattern. 7y squared plus 4, 7y squared minus 4. Now, something to look for is always to look to see if the subtraction problem is a difference of squares. Now, it's a difference. The square root of 4 is 2. Y squared is an even power, but 7 is not a perfect square. So therefore, you take the square root, you get a decimal. This is the final answer. And if you don't believe me, you can just FOIL this out, and you will get back to the original problem. Now we're going to deal with problem number 60. Problem number 60 is x squared plus 9xy plus 16y squared. Now first of all, since we have an x squared and a y squared, our problem is going to look like this, with numbers possibly in front of them. Now, we check to see, does this problem have a 1 in front of it? It doesn't, or it does. So this is easy factoring. What two numbers multiply to make 16 and add to make 9? We got 1 and 16, 2 and 8, and 4 and 4. Well, with 1 and 16, 2 and 8, and 4 and 4, unfortunately none of those make 9, so this problem is prime. It does not have any factorization that we can do without going into decimals, using the quadratic formula or imaginary numbers. So problem number 60 is prime.